Welcome to the Deep Dive. Today, we're starting a journey it's pretty crucial. It takes us right to the heart of modern infrastructure. Because before we can even get into all the jargon, the pods, the services, all of that, we have to establish the single most important definition in cloud computing. What exactly is Kubernetes?
It really is the foundational question. And it's not just academic. For anyone starting on that cloud-native associate path, or frankly, anyone who wants to understand how modern software gets built,
Huh.
this is square one. This is the tech that enables the kind of scale we all just take for granted now.
Okay, so that sets our mission for today. We're defining Kubernetes, but also its philosophy. Let's unpack this with the absolute basics first. The name, you see it everywhere, usually with that strange abbreviation.
Yeah, the name is actually full of meaning. Kubernetes is a Greek word. It means helmsman or pilot. And that tells you everything about its intended role. It's the one steering the ship.
Which is why the logo is a ship's wheel. It all clicks together.
Exactly. It drives that metaphor home.
And what about that abbreviation, the one that confuses everyone at first, K8?
K8s. It's actually really simple. It's just the 8 letters between the K and the S in Kubernetes.
Just a little industry shorthand.
Just shorthand. But once you see it, you can't unsee it. It's in documentation everywhere.
So if Kubernetes is the pilot, the helmsman,
Mm.
what's the ship it's guiding? What's the ocean?
Well, the ship is your application infrastructure. It's all the pieces of code, the databases, the services, everything that makes up a modern platform. And the ocean. That's the sheer overwhelming complexity of managing all of that at scale.
And that gets us right to the core problem this whole thing was built to solve, the orchestration problem. I mean, you and I can run a single container on a laptop, right? We type Docker run and it spins up. It's easy.
Right. Running one thing is simple. But managing hundreds think about big platforms, Uber, Netflix. They're not running one container.
No.
They could be running 50,000 containers
Mm.
all at once across servers all over the world. That's the orchestration problem.
And these containers, they're not static. They crash, they need updates, they have to talk to other specific services, and you can't just pile them all in one machine.
Precisely. Before tools like this, that was just a manual nightmare. A server goes down at 3 in the morning, and some engineer gets a page, wakes up, and has to manually move everything over, update records.
Usually with some brittle custom scripts that probably don't work anymore.
Exactly.
Yeah.
You'd need an army of people just clicking restart and trying to figure out where to put things.
So for anyone learning this, that's the key. The scale is what forces you into automation. Humans just can't keep up.
We can't. And that's where Kubernetes steps in. It takes all that chaos, all that potential for human error, and it imposes order. It is the definitive container orchestrator.
I love that term orchestrator. It makes me think of a conductor leading a symphony.
Mhm.
The conductor isn't playing the violin, but they're controlling the timing, the synchronization, the whole performance.
That analogy is spot on. It's perfect because it captures the value. The containers, they're the musicians. They're running your actual code. Kubernetes is the conductor. It's not running your app. It's managing where and when your app runs. It's infrastructure management.
Okay, so sticking with that analogy, what happens when one of the musicians, a container, just stops playing, it crashes?
And that's the first, most immediate benefit you get, self-healing. Because Kubernetes is always watching. The moment a container fails, a process dies, it runs out of memory, whatever, Kubernetes just restarts it instantly.
Okay, so that handles the small failures. But what if a whole section of the orchestra goes dark? An entire server dies. Power supply fails in the data center.
It's engineered for that too. If a whole server, what we call a worker node, goes offline, Kubernetes sees that all the applications that were running there are now gone. It doesn't wait for a person. It just says, okay, these are missing, and it immediately spins them up on other healthy nodes in the cluster.
Yeah,
It guarantees continuity.
that changes everything for reliability. It's a total shift away from manual firefighting. But
Wow.
how does it actually do that? What are the parts inside that make this work?
To get that, you have to look at the architecture. And it's actually split very cleanly into 2 main parts. You have the control plane and the worker nodes.
A classic division of labor. Okay, let's start with the worker nodes. If they're the heavy lifters, what's their job?
Their job is deceptively simple. The worker nodes are the servers. They can be virtual machines, physical servers that just run the applications, they run the containers. They are the muscle. All your code lives there.
And if they're the muscle, the control plane has to be the brain, the central intelligence making all these decisions.
Exactly. It's the brain.
Mm.
And inside that brain, there are a few key components that you really need to grasp. The most critical ones are the API server, etc., and the scheduler.
Let's take them one by one. The API server sounds like the front door.
It is the front door. It's the only front door. When you, as a user, want to do something, you talk to the API server. When components inside the cluster need to talk to each other, they go through the API server. Think of it like a central receptionist. It validates every single request and makes sure it gets recorded.
Okay, so if the API server is the receptionist taking the messages,
Yeah.
who's writing it all down? What's the source of truth?
That would be et cetera. It's a key value store, and it's where the control plane keeps all its data. The current state, the configuration, and this is critical, the desired state of the cluster.
So everything goes into et cetera.
Everything.
Yeah.
If et cetera goes down, your cluster basically has amnesia. It forgets what it's supposed to be doing. It is the single most crucial part.
So API server gets the request, et cetera, records it. But who decides where the work happens? If I ask for a new container, who picks the worker node for it to run on?
That's the scheduler. Its only job is placement.
Yeah.
When you ask for a new application, the scheduler looks at all the available worker nodes, it checks their CPU, their memory, and it finds the best fit. It's a logistics expert.
So we have the communication hub, the shared memory, and the logistics expert. How do those pieces actually enforce that self-healing we talked about?
That's the fourth piece. The controller manager. This is where it gets really cool. The controller manager is basically running a bunch of loops, little automated processes called controllers. There's a controller for nodes, a controller for deployments, and so on. Each one watches one specific thing.
So when a worker node dies, it's the node controller that actually notices.
It's the node controller. It's constantly checking the heartbeat from every node. When one stops responding, it sees a mismatch. The desired state is all nodes healthy, but the actual state is one node is down. And it then kicks off all the actions to fix it. It coordinates everything. And this idea brings us to the real governing philosophy of Kubernetes.
Declarative configuration.
Declarative configuration.
This is where it gets really interesting for me, because this concept of desired state versus actual state, it's a huge mental shift. It's moving from a checklist to a wish list.
That's a great way to put it. Let's compare it to the old way, the imperative model. There was a checklist. You'd write a script that said, first, install Java. Second, download this file. Third, start the app.
Right, and if step 2 failed for some reason, the whole thing just breaks. And a human has to go in and figure out why.
Exactly. The process is fragile because you're specifying the how. Declarative flips that entirely. You don't give it a checklist. You give it a YAML file. And that file is your wish list. It only defines the end result you want.
So what's an example of a declarative statement?
It's simple. It's, I want 3 copies of my web app running at all times. They need to be this version, and they need this much memory. You're not saying how to achieve that. You don't say, go to node 1 and do this. You just state the goal.
And that YAML file, that wish list, gets sent to the API server and written right into, etc. It becomes the official desired state.
Correct. And the moment that's logged, the heart of Kubernetes starts beating. It's called the reconciliation loop. It's this constant automated process where the controller manager is always comparing the desired state in, etc., with the actual state out on the worker nodes.
Let's walk through that loop then, because this is where the self-healing magic really happens. So I submit my YAML, desired state, 3 copies of my app, actual state is 0.
The controller manager sees a mismatch, desired 3, actual 0. So it tells the scheduler, we need to place 3 new containers. The scheduler does its job, and the actual state becomes 3. Now they match. The system is happy.
Okay, but then, an hour later, something goes wrong. A bug in my code causes one of the containers to crash. The actual state suddenly drops to 2.
The reconciliation loop sees it almost instantly. Desired is 3, actual is now 2. Mismatch. Without any human telling it to, the controller manager kicks off the process to schedule 1 new copy. A new one spins up and the actual state goes back to 3. It is constantly automatically reconciling.
So as an engineer, my job is no longer to watch the server and restart it if it crashes. My job is to make sure the definition of what I want is correct. The system handles the rest.
That is the profound shift. You stop worrying about the mechanics of keeping things running and you start focusing on correctly defining the end state. The system does the remediation.
So let's synthesize this. For you, the learner, starting this journey, what does all this, the orchestration, the architecture, this declarative model, what does it all mean? What's the big takeaway?
The big takeaway is that this creates an anxiety reduction layer. You achieve a fundamental decoupling. Your application is no longer tied to the specific server it's running on.
So the app doesn't care if it's on AWS or Google Cloud or even a server in my basement. The YAML file, the definition, stays the same.
Absolutely. You get portability. And you get this incredible power to scale up or down just by changing one number in that definition file. This whole philosophy containers, orchestration, declarative management, that is the modern cloud-native philosophy.
You're treating infrastructure as code, not as pets that you have to name and care for individually.
Exactly, they're cattle, not pets.
Okay, that's an incredibly clear picture. To quickly recap our deep dive for you, the listener, just to lock in this knowledge. 1. Kubernetes is the helmsman, the pilot. 2. It solves the orchestration problem at massive scale. 3. It uses a brain and muscle architecture. The control plane makes decisions. The worker nodes do the work. And 4, most critically, it operates on a declarative model, always running that reconciliation loop to make the actual state match the desired state.
And that reconciliation loop leaves us with a final, provocative thought. If the system can so reliably handle the mechanical failures, if it guarantees your 3 copies are always running,
Okay.
how does that change the job of a modern engineer? When all of the simple, reactive work of restarting things is automated away, what higher-level problems should you be focusing your time on to build truly reliable systems?
Something to think about as you dive deeper. Thank you for joining us for this deep dive.
We'll see you next time as we continue building out our knowledge of the cloud-native world.